Hello, everybody, and welcome to this week's lesson. This week, we're continuing our work on ratios and proportions. So, our learning goals for this week, by the end of this week, you'll be able to compute unit rates. Some examples of that include unit pricing, constant speed, people per square mile, and BTUs per cubic foot. You'll be able to use slope and graphing to determine unit rates. You'll use scale factors to determine the magnitude of a size change and convert between actual drawings and scale drawings. And you'll solve multi-step real-world arithmetic problems using ratios or proportions, including those that require converting units of measure. Okay, so there's a lot on here, but basically we are focusing on situations where we would be using ratios, unit rates, and proportions. All right, so we've got a warm-up problem here. For this problem and the rest of the lesson, the materials you're going to need are pencil and paper. Your GED math formula sheet might be useful to you. It's always good to have that out next to you. Any lesson notes you have from previous weeks. A calculator might be helpful as well. So this warm-up problem says, the graph below shows Robin's earnings compared to time spent working. Examine the graph to determine how many dollars Robin earns per hour. So pause the video and take a moment to think about this question, try and answer it for yourself, and then when you're ready, come back to the video and we're going to talk through how to answer this. Okay. So we want to know how many dollars Robin earns per hour. When we look at this graph, we see that the x-axis is talking about the number of hours that she's worked, and then the y-axis is showing the dollars that she's earned. So we've got hours versus total earnings here. So probably the quickest way to answer this problem is to go to the point on the graph where she's worked 1 hour and see how much money she's earned. So after 1 hour, Robin has earned $15. And so we know that her hourly earnings, right, 1 hour is going to give her $15. So she is earning $15. There's something wrong with my trackpad here. $15 per hour. And that is our final answer. So you can also see that on the rest of the graph here, if you look at how much her earnings increase each hour, you will see that the earnings increase by $15 every hour, right? So after 2 hours, she has $30. She's gone up by $15. After 3 hours, she has $45. So she's gone up by $15 again. So every time we go up an hour, we go up by $15. So we could say that the unit rate in this problem is $15 an hour. We could also say that the slope of this line, the slope of this relationship between hours worked and total earnings is $15 per hour. All right, so ratios and rates. Let's start with a question here. Have you ever compared two amounts? So just any time in your life, have you ever made a comparison between two numbers or two amounts? If yes, then what you've done is you've used a ratio. So a ratio is just a comparison of two numbers. It's a very, very general concept. And I've got a few examples here. So maybe we're comparing scores in a game. We could compare 3 points to 10 points. Maybe we're comparing number of girls in a classroom to number of boys. We could say 12 girls to 11 boys. Maybe we're comparing the number of students who passed a test to the total number of students. So we might have 8 students who passed compared to 25 total students. And with these 3 examples here, I've shown you the 3 common ways that we write ratios. So sometimes we write them using the word to. Sometimes we write them using a colon, and sometimes we write them as a fraction, so using this fraction bar here. I will say that the fraction representation is most common when you're using ratios in a math problem. They can be most useful if you're trying to do a calculation with them, and that's most often how I will write the ratio, but it really doesn't matter. They all mean the same thing. And if it does matter, so if a problem wants you to write it in a certain way, it'll be clear in the directions. All right, and so then the next term we have here is rate. So a rate is a comparison of two numbers where the numbers have different units. So it's really just a special type of ratio. In this first example here, where it says 3 points to 10 points, that was a comparison between the same kind of thing. Both of those numbers have the same units. They're both talking about points. But a rate is where we are comparing things with different units. So again, just a few examples here. We have 200 miles to 8 gallons. So comparing miles and gallons, those are different types of things, different units. $11 for 2 sandwiches, comparing dollars and number of sandwiches. 12 books to 29 students, comparing number of books and number of students. Those are different types of things, different units of measurement. And then finally, the last type of ratio that we're going to be concerned with is a unit rate. So a unit rate is a comparison of two numbers where the second number is 1 or a unit, a single unit. And sometimes you might see this shortened to just a rate. So rate and unit rates can sometimes be interchangeable. And again, I've got a few examples here. So 50 miles per 1 gallon, that's actually just the simplified version of the rate we had up here, 200 miles per 8 gallons. So 200 miles per 8 gallons will simplify to 50 miles per gallon. Same thing here with the dollars and the sandwiches. So $11 for 2 sandwiches, that simplifies to a unit rate of $6.50 per sandwich. And then here I've got 1 chickens per person. So let's say you are trying to figure out how many chickens there are in your town. One way you could express that is you can say there's 1 chicken per person. There's 1 chicken for every person in the town. Could be a lot of chickens depending on how many people you have. All right, let's get some practice here with calculating unit rates. So compute, calculate basically means the same thing. So sometimes you might need to calculate a unit rate. And the way you calculate a unit rate is by dividing. That's all there is to it. So very easy, especially if you got a calculator next to you. So let's look at this example here. It says Aisha needs to buy a lot of donuts for a family gathering. So let's say maybe she needs like 50 or 100 donuts. She just needs to buy a whole lot of them. At Frank's Donuts, she can purchase 12 donuts for $6.95. And at Priya's Bakery, she can purchase 10 donuts for $5.75. Which place offers a better price per donut? So what I'm going to do here, if I want to figure out the price per donut, what I would do is I would take each ratio here. So I've got 2 ratios, one for Frank's and one for Priya's, and I would divide them to find the unit price, the price per donut. So at Frank's, price per donut, so we've got $6.95 for 12 donuts. I'm just gonna abbreviate that here. And then at Priya's, we've got $5.75 for 10 donuts. So if we want to figure out the price per donut, we would divide. So when I do 6.95 divided by 12 donuts, I get 0.579. It's a long decimal, so I'm gonna say 0.579. But then remember, this is cost or price that we're talking about here. So we want to be thinking about dollars and cents. Our cents are hundredths, right? They only go out to the hundredths place. We don't usually deal with prices out to the thousandths place. So we want to round this price to the nearest cent. So if we've got a 7 with a 9 next to it, that means we're going to round up to 58 cents. So at Frank's, it's about 58 cents per donut. Okay, and then we're going to do the same thing for Priya. So when we do 5.75 divided by 10, we get, when you divide by 10, you're really just moving the decimal point over one place. So we get 0.575. That's a good pattern to notice. And again, we're talking pricing here, so we want to round to the nearest cent. Since we've got a 7 with a 5 next to it, we would actually round this up to about 58 cents. So what if we discover here? Well, we've actually discovered that there's not that much difference in their prices. Certainly after we've rounded to the nearest cent, there's no difference in the prices. If we compare the prices before rounding, we might see that there is the slightest difference. We're talking thousandths of a dollar here, smaller than 1 cent. There's the smallest difference here between the two prices. So for most intents and purposes, this is probably not an important difference, and you could just say that they're the same price and you can just buy whichever kind you like better. If you want to get real persnickety here, you could say that Priya's has the slightly better price. It's a very slightly lower price before you round to the nearest cent. So again, this is an example where there's maybe not one correct answer. There might be a couple of different ways to think about this problem, to think about your answer. And so it might depend on your situation and the situation in which you're answering this problem. Okay. So we just saw how to calculate a unit rate based on a description of the situation. So we were given a couple of ratios, right, comparing cost to number of donuts, and then we calculated the unit price by dividing. We've actually already seen how to determine unit rate when the relationship between two things is represented in different ways. So we've seen it with equations, table of values, and graphs. We actually saw that in our lesson, I believe it was the week of June 15th, where we talked about proportional relationships. So we're going to do a little review of that. So proportional relationships, as I mentioned that week, they are connected to ratios and proportions. It's not just a coincidence that they have the same name. So a proportional relationship is where we are relating two things, right? Just like a ratio relates two things. A proportional relationship is just one way to think about that relationship. So it's a special type of linear function or linear relationship where if we are looking at a graph, the identifying characteristics are that it is going to be a straight line through the origin. So I have an example on the screen here. The equation always looks something like this, where we have y equals some constant, some number times x, where k is a constant or non-changing number. So k, one way to think about k is we could think about it as the unit rate. We could think of it as the slope rate of change, or you might see it sometimes called the constant of proportionality. So let's think back to this problem we just looked at where we found that it was about 58 cents per donut. So if we wanted to talk about the relationship between the total cost and the number of donuts that we're buying, well, the cost is going to be the number of donuts times the price per donut. And in this situation, it was 58 cents. So the cost, the total cost is going to be 58 cents times the number of donuts that we buy. And that's going to be true at both Frank's and Priya's, right? Because they ended up having about the same unit price, about the same cost per donut. So the total cost is the unit price times the number of units or the number of donuts that you're buying. So for this example, the 58 cents is our unit price, our unit rate. We could also call that the constant of proportionality, the slope, the rate of change. It goes by all of those different names. Okay, and then here's another example of a proportional relationship, a relationship between two things that's governed by this unit rate or this constant. So we could describe the relationship with words. We could show the relationship with an equation. We could show the relationship with a table of values here, so a list of example ratios. Or we could show the relationship with a graph. We actually already saw this graph today. All right, so let's get a little more practice with determining unit rates. I would recommend pausing the video here, reading through these questions, trying to answer them yourself, and then when you're ready, come back to the video and we're going to answer them now. So number one, Calvin bought 5 pounds of chicken for $6.25. What was the cost per pound? So cost per pound, that means we want to compare the cost to the number of pounds. So we're going to start out with the ratio they gave us. They told us 5 pounds is $6.25. So we want to make sure we are following the order in the question, right? We want to know cost per pound, so dollars per pound. We don't want to know pounds per dollar. So the order here is important. Pounds per dollar is different than dollars per pound. So $6.25, the cost per the number of pounds. And then when we divide $6.25 divided by 5, we get $1.25. So our unit price here is $1.25 per pound. Okay, and then the second problem here, number 2, it says the graph below shows Michelle's savings over the course of 6 months. How much is she saving per month? So each month. All right, let's examine the graph. So on the x-axis here, the x-axis is the number of months. And on the y-axis, we have her total savings in dollars. So there's a couple of different ways we can figure this out. One way is just to look for how much has she saved after 1 month. Because if she's saving the same amount every month, then the amount she has after 1 month is going to be her monthly savings. It's going to be how much she's putting in every month. So if I go to 1 month on the x-axis, that's right here on our line. If I go over to the y-axis, right, that's the line that's halfway between 0 and 100, so that's going to be 50. So we can say that Michelle is saving $50 per month. Another way we can see that is each month, her savings is going up by $50. So when I go from 1 month to 2 months, her savings goes from 50 to 100. So she's increased by 50. And then same thing again here, we go from 100 to 150, 150 to 200, and so on. So the slope of this line, or the rate of change, is $50 per month. It's that unit rate. We could actually write an equation to describe this. We could say her total savings is equal to $50 per month times the number of months that she's been saving. Question didn't ask us to do that, but it's just another way to think about representing this information. All right, so we've talked about ratios, rates, unit rates, right? Those are all about making comparisons between two things. Let's talk about proportions now. So a proportion is two ratios that are equal to each other. So two ratios that have this very special relationship. So let's think of a couple of examples here. Let's say that I am making a recipe for some cookies, and in the recipe it says I need 2 cups of flour, 2 cups of flour for every 1 cup of sugar. I'll just abbreviate that. So 2 cups of flour for every 1 cup of sugar. Well, let's say I need to double my recipe. If I double my recipe, I want to preserve that relationship between flour and sugar. So if I double my recipe, if I want to have double the amount of cookies, I'm going to need to double the flour and also double the sugar. So I would need to use 4 cups of flour as well as 2 cups of sugar. Both of those amounts were doubled. And this is a proportion. So this is 2 ratios or 2 comparisons that are equal or equivalent to each other. Let's look at another example. So let's say I have a preschool. So we're talking about a preschool, and there is a policy that says for every 5 students that we have in the classroom, so every 5 students, we need 1 teacher. Well, if there are, let's say, 20 students in the room, how many teachers are we going to need? Well, we need 1 teacher for every 5 students. That means we're going to need a total of 4 teachers. So this is another proportion. Now, both of these examples included ratios that had a unit rate. So the 5 to 1 or 2 to 1, those are unit rates. It doesn't have to be a unit rate. That was just the way it was in these examples. So if you are already comfortable with your fractions and the idea of equivalent fractions and simplifying fractions, then this idea of equivalent ratios should seem very familiar. But there's another way that you might not be familiar with to identify ratios that form a proportion. So a way to identify ratios that are actually equal to each other. If 2 ratios are equal to each other, they will have equal cross products. So let me show you what I mean. But look at the cross products of this first proportion. We say 1 times 4 equals 4. And 2 times 2 also equals 4. So the cross products of these 2 ratios are the same. That's another way we know that these 2 ratios do indeed form a proportion. Same thing here, 5 times 4 is 20. And 1 times 20 is 20. So anytime you have equivalent ratios, anytime you have a proportion, this will be true. The cross products will be equal. Okay, So let's get some extra practice with that. Let's determine if two ratios do indeed form a proportion. So Douglas is making iced tea from a drink mix. The instructions say to add 2 tablespoons per 8 ounces of water, and Douglas mixes 5 tablespoons with 20 ounces of water. Did he follow the instructions? So did he, with his ratio of drink mix to water, did he preserve the original relationship between drink mix and water? So let's check here. I'm going to find my cursor first. There it is. So first thing I'm going to do is I'm going to write out my two ratios. So 2 tablespoons for 8 ounces. And we want to know, does this form a proportion with, is this equal to 5 tablespoons per 20 ounces? So one way to check that is what we just talked about, looking at the cross products. So if we do 8 times 5, we get 40. And if we do 2 times 20, we also get 40. So that means these two ratios are equivalent. They are the same. And so they do form a proportion. So we could say that yes, he did follow the instructions. He preserved that relationship between tablespoons and ounces of water that was laid out in the recipe. Okay, so we just saw how to determine if two ratios form a proportion, so how to determine if two ratios are equivalent. But we can also use proportions to actually solve for missing information. So if we have a situation that we know is proportional, we already know it's proportional, we can use that fact, we can use the fact that the cross products should be equal to help us find a missing piece of information. So let's return to that same example, but we're gonna change it a little bit. Let's say we had the same recipe. So instructions say to add 2 tablespoons per 8 ounces of water. And then let's say Douglas wanted to make 40 ounces of drink. So he's going to use 40 ounces of water. So that's the change. Let's say he wants to figure out how much drink mix he should use. So one way he can do that is he can set up a proportion and solve it. So I'm going to show you what that means. So in the recipe, it says 2 tablespoons for 8 ounces. And now Douglas wants to know how many tablespoons, so I'm just gonna use X as a little placeholder there, how many tablespoons for 40 ounces? Now there's a couple ways you could go about this. One way you might do it is you might say, well, what's happened here is Douglas has multiplied the amount of water by 5, which means he's going to need to multiply the amount of drink mix by 5, right? 8 times 5 is 40. And so you could say 2 tablespoons times 5 is 10 tablespoons. So that's one way you could do it. That way works nicely, especially if the numbers are easy to deal with, if they're nice whole numbers that go into each other nicely. But that's not always the case. Sometimes you might be dealing with decimal amounts or numbers that are big or they just don't work that well together. So another way you can do it is to make use of that fact that the cross products must always be equal. So if this is a proportion, if Douglas is going to follow the recipe, then if we do 2 times 40, right, 2 times 40, 2 times 40, it should be equal to what we get when we do 8 times whatever that missing value is. So 2 times 40 should be equal to 8 times the missing value. So what we've done here is we've set up a little equation that we can now solve for the missing value for the variable x, right? A variable, we've talked about that word before. A variable is a letter that stands in for a missing or an unknown number. So we know this situation should be a proportion. If it should be a proportion, that means its cross products have to be equal. So we're going to use that fact to help us figure out the missing value. And again, since these numbers are not too bad, they're pretty small, they work together nicely, the answer might jump out at you. You might see that, well, 2 times 40 is going to be the same thing as 8 times 10. But let's say that doesn't jump out at you. So if it doesn't jump out at you, then first thing we're going to do is we're going to do this multiplication here over on the left-hand side. So 2 times 40 is 80. So we know that 80 should be equal to 8 times whatever x is. And now if you're still not sure what x has to be, right, x does have to be 10, but if that doesn't jump out at you, then you can determine what x is by dividing. So x is going to be equal to 80 divided by 8. And indeed, that is 10. So 80 divided by 8 is 10. That means the missing value here should be 10. Okay, so to solve a proportion for a missing value, what you do is you multiply. So you cross multiply, and then you divide. Cross multiply, and then you divide. Okay, so we're going to do another example very similar to the one we just looked at, using the same situation. So Douglas is making iced tea from a drink mix. The instructions say to use 2 tablespoons per 8 ounces of water, but now Douglas wants to use 24 ounces. How many tablespoons of drink mix should he use? So take a minute to see if you can figure that out based on what we just did together. And now we're gonna go through it together. So I look at this problem and I see that we are comparing ounces of water with tablespoons of drink mix. So I know I'm comparing tablespoons of drink mix with ounces. Those are the two things that are being compared. Now I'm going to set up my proportion. Remember, a proportion is 2 ratios that are equal. So one ratio I'm just told it's a complete ratio with 2 numbers. So it's 2 tablespoons per 8 ounces. And now the other ratio is incomplete. So he wants to use 24 ounces. And he needs to know how many tablespoons that is. So I'm using the letter X to hold that place there. You could use a question mark or a box, whatever you want to use. X is probably most common. It's what you'll see a lot in worksheets and textbooks and in other videos that you might watch. Okay, so we have our proportions set up, and now we can cross multiply and divide to solve for that missing number. So we know that 2 times 24 should be equal to 8 times whatever x is. And I'm actually just gonna skip that multiplication symbol because when we have a number right next to a variable, we know that it means multiplication. All right, so I'm still on my multiplying step here. 2 times 24 is 48. So now we know that 48 is equal to 8 times whatever x is. Now, if you know your times tables, then should be clear that x has to be 6. But if you were not sure, we can divide to figure it out. So 48 divided by 8. That's what x is. And so we see that x must be 6. So he should use 6 tablespoons of drink mix if he's going to use 24 ounces of water. So the steps here that I went through, I used the question to help me identify what 2 things I was comparing. So I was comparing tablespoons with number of ounces of water. And then I set up my proportion. Remember, proportion is 2 ratios that are equal. So I had 1 complete ratio based on the information I was given, and I had 1 incomplete ratio with a missing value. And then I did my calculation. So I cross-multiplied and I divided to find that missing value. Okay, so next thing we're going to talk about is scale factors. So a scale factor refers to multiplying both parts of a ratio by the same amount. And what it does is it creates equivalent ratios or proportions. So I want you to think about, have you ever heard of scale models or scale drawings before, or even map scales? So that's what this is talking about. This is talking about preserving the proportions of something, but just kind of like zooming in or zooming out, making it bigger or smaller. So we're gonna see some examples of problems that involve scaling things. So let's look at this problem here together. It says, on a map, the distance between Narragansett and Shiloh is 3.5 inches. So you're looking at a map, you get out your ruler, you see like if you draw a straight line between them, it's 3.5 inches. The map scale says 25 miles equals 1 inch. What is the actual distance between Narragansett and Shiloh? Okay. So this is a proportion problem. This is a problem where we're comparing 2 things. We're comparing miles and inches. We're given 1 complete ratio. So we're told that we have 25 miles or 1 inch when we look at this map. And then we have 1 incomplete ratio where we know the distance between Narragansett and Shiloh is 3.5. Come on, trackpad. 3.5 miles. Three point five inches. And we want to know how many miles is that? What's the actual distance between them? So take a minute to see if you can do that calculation, if you can figure it out. Okay, so to do the calculation, we would first cross multiply. And I'm going to skip the writing out a little bit here just to show how you could shorten the process once you get comfortable with it. So I could go straight to just doing the multiplication. I've got my calculator here with me. I could say, okay, I'm going to do 25 times 3.5. That gives me 87.5. 87.5. And I know that that's going to be equal to 1 times x. But what happens when you have 1 times something? 1 times something is just that something, right? Multiplying by 1 doesn't change anything. So actually in this situation, we don't even need to bother with the division. We see that if 87.5 equals 1 times x, that means 87.5 equals x. So in this situation, we just needed to multiply. We see if on the map, those two towns are 3.5 inches apart. That means in real life, they're 87.5 miles apart if it's 25 miles to the inch. Okay. So it's all well and good for me to go through these examples with you and tell you that you can use proportions to solve them. But if you're taking a test, how can you know if a proportion is the right tool to use in a problem? So these are the things that you should look for to know whether or not you should use a proportion. So if it's a proportion kind of problem, then the problem is going to be comparing two things. So miles and gallons, inches and feet, students and test scores, etc. It's going to be comparing two things. And then there are going to be 3 numbers given. So you're going to have one complete ratio, one complete comparison, and one incomplete ratio, one that's missing a value. And then the thing you're asked to do is you're asked to find the 4th number. You're asked to complete that incomplete ratio. So those are the characteristics of a typical proportion kind of problem. All right, so now we're going to do a few practice problems together before we finish up for today. Number 1, 125,000 people live in Shiloh and it covers 100 square miles. How many people are there per square mile? So people per square mile. So we've got 125,000 people. Per 100 square miles, so that's people per 100 square miles. So if we want people per 1 square mile, people per square mile, we divide. So 125,000 divided by 100 is going to be 1,250 people per square mile. So this was a problem where we were asked to find a unit rate, to calculate a unit rate. All right, number 2. Ronette is filling her pool for the hot summer days ahead. The graph below or to the side compares the number of hours the hose has been running with the total gallons in the pool. The hose is filling how many gallons per hour? Okay, so let's look at this graph. So I can see that as the hours are passing, so as the hours increase, the number of gallons in the pool are also increasing. That's what this red line here tells me. It's going up. So after 1 hour, the pool has, let's see, this is halfway between 0 and 20. That means the pool has 10 gallons in it. So that means the pool is getting 10 gallons every hour, right? If it's going at a consistent rate, it's going to be 10 gallons every hour. So after 1 hour, it's 10 gallons. After 2 hours, it's 20. After 3 hours, it's 30. After 4 hours, it's 40. After 5 hours, it's 50, or so on. So the rate of change here, or the slope, is 10 gallons per hour. 10 gallons for every 1 hour. So we get 10 gallons per hour. All right, number 3. For an art project, Constantine is making a scale model of his bedroom. So he's taking his actual bedroom and he's shrinking it down to a little model. His actual room is 15 feet long and 12 feet wide. In the model, the room is 5 inches long. How wide should the model be? Okay. So what we are trying to do here is we are trying to preserve the relationship between the length and the width of the bedroom. So we know, right, we're comparing length and width here. Length and width. Make that a cursive L so it doesn't look like a 1. Length and width. So in his actual room, the length is 15 and the width is 12. In the model, the length is 5 inches, and we want to know what the width is in the model. So how many inches? So I'll say that W for width. Okay, so we set up our proportion. Now we're going to solve for the missing value. It doesn't matter that the value's on the bottom here. The process is exactly the same. We're using the same principle that the cross products should be equal to each other. So 12 times 5 should equal whatever we get when we do 15 times this missing number. So 12 times 5, do we know what 12 times 5 is? 12 times 5 is 60. So we know that 60 is equal to whatever we get when we do 15 times W. So we cross multiplied, and now we're going to divide. We know that W is going to be 60 divided by 15. You might know that off the top of your head. You might know that 15 times 4 is 60, but if you don't, you can go ahead, do the division or use a calculator. And so we find that the missing width there is 4. So if his actual room is 15 feet long and 12 feet wide, then the model, if it's 5 inches long, it should be 4 inches wide. Okay, so our final 2 problems here. Number 4, it says there are approximately 2.5 centimeters per inch. If a table is 100 inches wide, how many centimeters is that? So in this problem, we are comparing inches and centimeters. We're comparing inches and centimeters. So we know it's 2.5 centimeters per 1 inch. So 2.5 centimeters per 1 inch. We have a table that is 100 inches wide. How many centimeters is that? So you might be able to see that all that's going to happen in this problem is multiplication, right? What we've done here is we've taken the inches and multiplied them by 100 to get 100, right? 1 times 100 is 100. So that's really all we need to do with the centimeters to find the number of centimeters as well. So you could do it that way. You could just jump straight into the calculations and see that all you need to do is multiply 100 by 2.5. But we can also think of this as a proportion and go through the steps of solving a proportion. So we'd say 2.5 times 100 is 250. And that should be equal to whatever we get when we do 1 times x. But as we saw in a previous example, right, 1 times x, 1 times something, is just that something. So 1 times x is just x, and that means x is 250. So if you have a table that is 100 inches wide, that's the same thing as saying your table is about 250 centimeters wide. Okay. And then on to our final question here. There are 4 quarts in a gallon. If a recipe says to use 8 cups of honey per gallon of water, how much honey should you use if you're only using a quart of water? Okay, so now this one has a little bit more going on at first. So we've got a recipe that tells us to use 8 cups of honey per 1 gallon. How much honey should you use if you're only using a quart? So this is a little bit of a sticky situation because we've got cups, we've got gallons, and we've got quarts. This isn't just talking about 2 units, this is talking about 3 different types of units here. So the first thing we're going to need to do is we're going to need to do a conversion so that we're only dealing with 2 different types of units. So what I'm going to do is I'm going to use the information I was given to change quarts into gallons. So if I know that I have, if I know that it's 4 quarts per 1 gallon, I want to know, well, if I have 1 quart, how many gallons is that? So you might be able to see that really what's going to happen here is we're going to take our gallon and we're going to divide it by 4. A quart is called a quart because it's a quarter of a gallon, so it's going to be 0.25 gallons. But let's see how that happens with the proportion set up here. So we're saying that we're going to cross multiply, right? So 1 times 1 is 1, and that equals 4 times x, right? That equals 4 times x. And then if we want to know x, we divide. That's the second thing, right? We cross multiply and then we divide. So x is 1/4, or 1 divided by 4, which is 0.25. So a quart is a quarter of a gallon, or 0.25 gallons. So now, let's come here to the second part of our question. So 8 cups of honey per gallon. 8 cups of honey per 1 gallon of water. How much honey should we use? So the honey is the thing that's missing. If we're only using a quarter of a gallon, so 0.25 gallons. Okay, and now we're going to cross multiply and divide. So 8 times 0.25. And what is that equal to? Well, really what we're doing is we're taking a quarter of 8. 8 times a quarter. which is equal to 2. So 2 times 1, 2 should be equal to 1 times x. And we know that 1 times x is just x, so 2 is equal to x. And that should make sense, right? So if it's 8 cups per gallon, if you're only using a quarter of a gallon, that means you're going to use a quarter of the cups. A quarter of the cups. A quarter of 8 is 2, right? If you take 8 and you cut it up into 4 equal parts, each part is going to be 2. So if you are downsizing the recipe, if you're cutting it down by a factor of 4, you should use a quarter of the amount of honey. You should use 2 cups of honey. All right, guys, so that is all we have for today. This lesson corresponds with our assignments on the Google Classroom. So make sure that you have checked out our intro post for this week. Make sure you've looked at the vocabulary list and the online learning links. The online learning links provide you links to other YouTube videos and other resources that give you more examples and more explanations for what we've talked about today. Sometimes it can be good to hear other people talk about the same thing. And then make sure you do your assignments. So there's going to be assignments up on Monday, Tuesday, Wednesday, and Friday. All right, I hope you all have a great rest of your week, and I will talk to you all soon.